Hello, everyone, and thank you for attending today's webinar on Chef and Azure, Automating Audit and Compliance with InSpec. My name is Jamie Bright, and I work on the marketing team here at Chef, and I'm pleased to introduce today's speakers, Matt Rathbun, the Chief Information Security Officer for Azure Government, and Bach Inamov, our Senior Partner Architect here at Chef. But before I turn it over to Matt and Bach, I have a couple of housekeeping items to cover quickly. At the bottom of your screen are multiple application widgets you can use. All the widgets are resizable and movable, so feel free to move them around to get the most out of your desktop space. You can expand your slide area or maximize it to full screen by clicking on the arrows in the top right corner. If you have any questions during the webinar, you can submit them through the Q&A widget at any time. We have dedicated time at the end of the presentation to answer your questions, but if we run out of time before getting to your question, it will be answered later via email. Please know that we do capture all your questions. A copy of today's slide deck and additional help materials are available in the resource list. We encourage you to download any resources or bookmark any links that you may find useful. For the best viewing experience, we recommend using a wired internet connection and closing any programs or browser sessions running in the background that could cause issues. Webinars are bandwidth intensive, so closing any unnecessary browser tabs will help conserve your bandwidth. Finally, this webinar is being recorded, and an on-demand version of the presentation will be available approximately 1 day after the webinar, and you can access it using the same audience link that was sent to you earlier. For those of you that are just joining, welcome to today's presentation on Chef, Linux, and Azure. Let's go ahead and get started. Bach, why don't you kick us off by telling our audience a bit more about yourself and what we'll be covering here today.
Thank you, Jamie, and welcome everyone to our webinar. We're going to talk about automating your audit and compliance with Chef's framework InSpec. We're happy to have Matt Rathbun with us. Matt is the Chief Information Security Officer and works with the Azure government team. And he'll kick us off with a little bit of introduction about what we call, let's see, all right. I got to learn how to do the slides. Here we go. So Matt will kick us off with information about the Microsoft Trusted Cloud Platform, after which we'll paint the remainder of the picture, talking about InSpec and automation of audit and compliance control. Thank you, Matt.
All right. Thank you, everybody. As Mark said, my name is Matt Rathbun. I'm the Chief Information Security Officer here at Microsoft for our Azure Government offering. Moving on to the next slide. I want to talk a little bit about the journey to the cloud and why organizations might move in the first place. Most of my customers began with one of the top 3 reasons here, either moving because they wanted to differentiate themselves with their competition, do a digital transformation. They were looking for agility, so we have unstable demand cycles, or wanted to do some dev test and be able to quickly slide in and slide out pieces and parts, or cost savings. You're at the end of a depreciation cycle. You don't want to rebuy some hardware. You want to be able to move to not a 5-year investment cycle, but something more like an annual investment cycle. But we believe the #1 reason that anyone should consider moving to the cloud is, in fact, security. There are things that are being done at the hyperscale and being done by large-scale cloud providers like Microsoft that are simply impossible to replicate on premises, that dramatically improve the overall security capabilities and functionalities of our IT infrastructure. As a couple of examples, just to put some things in mind, Microsoft as an organization has thousands of engineers focused specifically on cybersecurity, and we spend a little over $1 billion a year on that particular problem. Very difficult for most of our customers to replicate. We're working on advanced engineering processes to remove humans as much as possible from access to our production environments so that we can eventually get to just trusted automation and remove the unstable element, or really the riskiest element of any of our system operations, which is humans who are ultimately bad at doing repeatable tasks reliably and well. We also have the capability to do large-scale analytics across our total problem space and the rest of our fleet analytics, or our research capacity, through other Microsoft installed products. And we have our own effectively counterintelligence arm where we do research and fingerprinting of the advanced persistent threats and look for their activities out in the wild. So not just looking for flaws in our own software, but actually doing hunting techniques of the advanced threats in the wild and then protecting ourselves against those threats before we ever see any attempts at compromise of our platform. The reasons why we think the Microsoft cloud specifically is the hyperscale cloud to consider from that perspective are three pillars. The first is it is global. So we have the largest installed, the largest number of regions available of any cloud provider on the planet. We have more overall space from that perspective. We are the most trusted, so we have the most certified certifications of any cloud provider on the planet. And we are hybrid. So what that means from our perspective is a couple of things. First of all, we invest both in the on-prem experience and the cloud-based experience and ways to link those two things together, understanding that some legacy architectures simply won't be able to move easily to the cloud, and at the same time understanding that nobody wants a one-size-fits-all solution. So Microsoft works deeply with our partners. About 40% of our global fleet runs on products that are not owned by Microsoft, which is how we get into conversations like today, where we're working with Chef and talking about automation using Linux in the Microsoft cloud. Having some technical details with the slides here. The next slide I want to jump. Can one of the other presenters advance the slides? Very sorry here, but that interface just crashed out for me on the podcast. So great, thank you. As you can see, Microsoft, we have, no, I'm sorry, the one back, slide 6. I got it. Okay. We have 54 different regimes that are certified for our platform. These are government entities or attestations provided by attorneys or independent reviews by commercial entities of the security posture of our system and the ability for our cloud to handle sensitive data. We have sort of listed here a number of our most common certifications that get asked for in descending order of complexity. So beginning with ISO, moving down to SOC, PCI, FedRAMP for the U.S. civilian government, and then DISA for the Department of Defense specific concerns or considerations. And what you can see against those is not only in each category do we have more services, but the percentage of service that we have relative to our competition increases as we go down that chart, where each level gets more and more difficult to meet those individual services requirements. We also put more of our own risk on the line, or we share our risk with our customers. So we accept more responsibility for each of these regimes and each of the security sets of responsibilities for our customers. And we are willing to sign higher limits of liability than most of our competitors in this space, really being willing to put our money where our mouth is when it comes to trust and security of our platform. Understanding that not everyone has the same, or not all organizations have the same budget and expertise that Microsoft does to approach this problem, to get those 54 regimes and counting, we developed a program that we call Azure Blueprint. It is intended to assist our customers with achieving security and compliance when they build on top of Azure. And we work across the 5 pillars outlined here. On the next slide, I'm going to run through examples of what we have available and coming very, very soon in the federal civilian market. So initially, in the blue circle, we have architecture. What this means is for each of our services that are certified in our various compliance regimes, we publish the architecture of that service. We identify exactly how that works and functions so that you can perform your own risk tolerance review of that architecture. We understand that the cloud initially began as a sort of a line of demarcation on a Visio diagram indicating you don't need to worry about what's going on here. But we at Microsoft take a very opposite approach. We believe in radical transparency. We want you to see exactly how the sausage is being made so that you can feel safe and comfortable with the processes and procedures that we're enacting. We also then publish, as part of that architecture, our customer responsibility matrix. So that is where we have identified where Microsoft owns security versus where our customers own security. In a cloud-based world, there's always some sort of shared set of responsibilities, and as we work up the stack from IaaS to PaaS to SaaS, those all change, and we publish that for each of our individual services. Moving down the slide, we are in the process of developing a catalog of automated deployment templates using our Azure Resource Manager service. Coming in the middle of next month, we will be releasing one for FedRAMP at the high baseline level, where we deploy a common application architecture, where we have taken all of those customer responsibilities I just discussed up in architecture, anything that relies to the customer, everything that we can do through technology, whether that's deploying a firewall or enabling encryption or configuring monitoring, anything that can be done with technology in the system itself, all of that is pre-configured to be compliant against that regime, so in this case against FedRAMP, leaving for the individual service owner just process and policy related requirements. Moving over to the right in the certification window, we've taken it a step further and said, not just do we want you to rely on the certifications that we have, but against those regimes, so in this case, again, FedRAMP, we took our paperwork and rewrote it so that we have available for you the regulatory paperwork that's required to be submitted to achieve your own certification, written in such a way that it doesn't describe what Microsoft does to meet Microsoft's requirements, but it's what Azure does on your behalf as a customer to meet your requirements for you automatically. About 30 to 40% of those controls are met with no obligation for the customer at all. There's an additional set where there is some set of shared responsibility, and then as we discussed, there's the remainder where you do have responsibility as an individual customer. Within that paperwork, anywhere a customer has responsibility, we don't end the discussion there. We have added examples of what a passing answer would look like, what the appropriate level of detail is required for that particular regulatory body. And we tie you back to any links to TechNet articles or other pieces of technology that would enable you to meet those sets of requirements. And as we continue to build out our automated deployment catalog in the orange circle, we'll begin linking those two items together so that you will be able to see our certification connection and our deployment connection all together. Finally, down in the gray sphere, we have a couple of different flavors of expertise. So Microsoft is a large volume customer of external auditors and subject matter expert vendors in the cybersecurity space. If our customers do not have their own auditor or cybersecurity SME that they already like, they can get access to ours at our volume discount rates coming through the Blueprint program. So in order to be a Microsoft vendor, you must commit that anybody who comes to you through the Blueprint program is treated as part of the Microsoft book of business. What that means is you get my volume discount rate, even if you're only going to spend $10,000, as opposed to my $10 million I'm spending with some of these vendors every single year. And you also get treated as if you are a large-scale customer on the size and scope of Microsoft, because if these agencies or organizations that are functioning on our behalf do not appropriately support our customers and clients, they will no longer be supporting Microsoft either. So you get all the advantages of being a large-scale company without having to make those sets of investments. We also then have access to my team. So we have a team of engineers who do nothing but assist customers with achieving certification and compliance when they build on top of Azure. What that means is we will do security and architecture reviews with you. If you're stuck trying to figure out for your individual application, how can I possibly meet a given security goal? How am I going to get to a point where I can meet this compliance obligation? We can help you with that. We've met most of those ourselves because we build natively on top of Azure to begin with. We also have about 160 organizations worldwide with those exact same kinds of technological problems or challenges, and we're able to help you doing security architecture reviews from that perspective. We will also meet with you and either regulators or internal information assurance experts and staff to talk about how your application that's built on top of Azure is very similar to what they have already approved and authorized for Azure, and talk about how that is good, modern, enterprise capabilities and the appropriate way to operate in the cloud. So you can leverage some of our political capital that we've gained by already getting through these 54 regimes to help streamline your process. Testing this inside the federal government, we've seen a couple of important statistics. First of all, the time to go from true dev to fully certified production is reduced by over 50%. And we're seeing cost reduction in that certification process by up to 73%. The last slide I wanted to talk to is we're doing this across several different verticals and organizations. So we have available today capabilities for the financial services industry around PCI. We have coming very soon this fully vetted architecture and capability for FedRAMP. We are deploying the same capabilities for the U.S. military and against all these different areas, HIPAA, UK private sector, lots of different organizations and capabilities. And coming soon, GDPR, when that becomes the law of the land here and very soon in Europe. But with that, taking it even a level beyond what we're capable of doing at Microsoft and doing through Azure Blueprint is Chef Inspect. And with that, I'll turn it over to Bach.
Thank you, Matt. So let's get into the details here. I think if I were to ask you to take away 3 things from this webinar, those would be that essentially what we're looking to do and the way that it complements what Matt has just presented is we're enabling organizations to move the audit and compliance problems and solutions over to the left. We know that today security and compliance is a challenge, and we want to help you turn that into a competitive advantage. And last but not least, as you walk away from this, I want to leave you with the right kinds of examples where you can try all of this hands-on and get a feel for what really it enables you to do. So I'm Bach Hanamov. I'm a senior partner architect at Chef, and I'll begin this part of the presentation now. As you may know, Chef is a fairly young company. We've been around since, about 2008, maybe? Today, we're at the forefront of Agile, Lean, and DevOps. I've worked with almost every large customer that Chef has been engaged with. I've seen the company grow from single digits to now we're at almost 300 employees. We're all over the world, headquarters in Seattle, but San Francisco, London, Berlin. But what we are seeing is the very large enterprises having a tendency to use solutions like Chef. And that's simply because, every one of these large enterprises is a software business. Viresh Sita, former CIO at Alaska Airlines, he said, hey, Alaska Airlines is no longer an airline, right? It's a software company with wings. And this applies to every kind of business that you may be in, whether you're banks or retail or Netflix, right? You're all software businesses delivering value around finance, delivering value around retail, delivering value around mobility, but at the end of the day, we're software companies. And so to enable all of this, our main product at Chef is Chef Automate. Now, most of the market and most of the attendees in this webinar are probably familiar with Chef as the infrastructure automation piece, and we can see it on this slide in the bottom left corner. That's the piece that Chef has been named for, and that's the piece that's most of the market is familiar with. What we want to do is make sure that that we're also working on other things such as InSpec for compliance automation, which is what we're going to focus this webinar on. The other really interesting piece is Habitat that we're doing for application automation that will have other topics and other webinars in the future, and there's already enough available content out there. Now, what's interesting looking at this slide and comparing it to the slides that Matt has presented, we're seeing that very similar outcomes that our customers are looking to achieve by using technology, by being software companies, right? So increased speed, improved efficiency and decreased risk, right? And if you remember that slide from Matt, he had agility, cost savings, and security and differentiation as being the key outcomes that customers seek. And you can see we're aligned there. Essentially, what we're saying is we are asked by our organizations to be delivering software faster, to be delivering value to customers faster. And so the way we have to do that is by expressing all of our application code and infrastructure code and security as code, right, and have machines act on that, have that code be passed in continuous delivery pipelines for increased speed, right? So Matt was saying, hey, let's decrease the impact of humans, of people on production systems, and we totally agreed there, right? To be able to achieve these kinds of scales and these kinds of speeds and efficiencies, we have to be looking at decreasing the impact of humans on production-grade systems. And what that means is really enabling our teams to focus on net creative work and problem-solving work, which is around building features, building solutions, writing tests, writing audit controls, and doing all of that as code, and then machines should be responsible for building and promoting that code. So improving efficiency is around writing those kinds of tests, right, and making sure that when things go out, they actually go out in a production-ready state as opposed to being in a broken state. And of course, measure the effectiveness of your releases, right? How many releases have you done in the past month, and how many out of those have been bad, right? Those are the kinds of metrics we should be looking at as software organizations as we're looking to improve efficiency. And finally, of course, and this is what this webinar is focused on, is decrease of risk. And to do that, let's also express our security and compliance concerns in code, right? And let's make sure that all of our net new code and existing systems get scanned and get compliant with the code that we've written for security and compliance concerns. And again, that has to be promoted through continuous delivery pipeline. So what I'll do in the next couple of slides is I'll quickly remind you about what Chef is. We'll touch about Habitat a little bit, but then we'll dive in deeper into InSpec. All right, so I'm going to progress the slide. Again, Chef is infrastructure as code, right? It's a language and execution framework that allow us to configure our machines, our systems to the desired state that we need them to be in. What I'm going to say is that if you're not doing Chef today or something similar to Chef, be that PowerShell DSC or any of the other tools out there, this is really the 101 of automation. You have to be able to produce reusable, repeatable systems. And what that means is your systems need to be configured programmatically, because what that enables is consistency of environments for your life cycles, right? So you want to see your development environments to be configured very closely to your test environments, very closely to your pre-prod and production environments. Once you achieve that level of consistency among your environments using Chef or any other tools out there, only then can you start thinking about effectively increasing the speed of your software delivery. So this is really 101. If you're not doing this now, you need to start doing, be that Chef, PowerShell DSC, or anything else. Please automate your systems so that they are consistently reproducible. Habitat is our latest offering. It's open source now, and it's very young, but there's a lot of activity around it in the market, especially in the open source community. What really Habitat is to me is a way. It's a new way to package your applications in such a way that it adds runtime intelligence for your applications. And what I mean by that is when a developer uses Habitat, they have the power to express how the application that they're building needs to be managed, how it needs to be installed, how it needs to start, how it needs to be monitored, what kind of external information it needs from service discovery mechanisms, what kind of topologies this application is supposed to run in. The developer using Habitat is empowered to express those application requirements, application runtime requirements, really. And once they build that application, it will run, and it will run in an automated fashion based on the capabilities that the developer has expressed for the application. So very simple examples: when your applications are running and they're needed to find their database, all they have to do is ask one of their peer habitats, hey, where's my database? And they will get their required information. So things like service discovery, orchestration, application start, stop, monitoring, all of those things are built into the packaging platform. And so if you're not doing Habitat today, I really encourage you to take a look at it. What it does is it really enables us to make our applications portable if we want to be using them in containers or in microservices world or anything to do with cloud and rapid deployment. Really, really interesting and compelling system here. Again, we're not going to focus on Habitat in this webinar, but I do encourage you to visit habitat.sh, which is the website where we're hosting documentation, tutorials, and a depot of many Habitat packages produced. Again, it's a packaging system that adds runtime automation intelligence to your application. Go ahead and check it out. But really, what we want to focus on in this webinar is InSpec. InSpec is our shot at compliance as code. And what that means is that it's a set of language structures as well as executables that allow us to express our security concerns in code. And by doing that, we can shift that responsibility and that burden from our production systems, where we scan them once a year or 2 times a year, depending on when your audits happen, to continuous scanning by moving all of this over to the left, right? Once we move that complexity from production runtime over to development and testing side, we are better enabled to release more compliant code. We're better able to detect vulnerabilities and audit problems as part of our release process, remediate those, and then make sure that we're releasing compliant code. And what that allows us to do is, again, to continue to enable our security teams to be able to write code so that this security problem turns from being a problem and a concern for cloud consumption to an enabler and a competitive edge. And let's dive a little bit deeper into all of this. So I'll tell you a little story here, and as an aside to this slide, traditionally when I've seen companies do audits, it would happen once or twice a year, or maybe every quarter, depending on the organization and the compliance bodies that they're trying to adhere to. And what would happen is a certain subset of production systems will be pooled, and humans would log into those systems and check the state of specific resources. So they would say, hey, I want to make sure that the password complexity requirements are met. I want to make sure that Telnet service is not running. I want to make sure that all of our web services are running over TLS SSL on port 443 and not on port 80, right? Those kinds of concerns, what we were doing with those traditionally is addressing them, as I said, once or twice or 4 times a year based on our compliance requirements. What that means is the remainder of the time we are not concerned with those requirements, and it seems like we're doing it just for show. And so with compliance as code, we're really changing how this should look like, right? First of all, we're really changing the role of the compliance officer. Instead of that role being a reactive kind of engagement where, as I said, we would be looking at a subset of production systems. Let's make that a proactive solution, right? Let's make that part of our pipeline so that the code can act on net new releases before they're actually released. Again, a lot of the existing compliance audit and compliance processes fairly manual. There are tools out there that allow us to automate some of it, but to a degree, it's still very manual. We're still taking screenshots. We're still dumping them into huge Word documents. What that does is it slows us down, right? It slows the organization down from being able to release fast. And so we need to change that outlook. We need to make sure that those security concerns are part of the release process and not after the fact. And of course, again, traditionally, an audit team is really concerned about passing the audit, which means it's a short-term compliance concern. Whereas once you've expressed this as code, and you can scan your pipelines, you can scan net new code in your pipelines. You can also scan your existing production systems continuously, right? You can do it every time you have any new release, or you can do it periodically, do it in a scheduled manner, so that you have long-term outlooks on your security process improvement. Traditionally, auditors have been operating in this world of documentation, right? They would come to us and they'd say, hey, can you make sure that we're only running SSH version 2 on all of our production systems, because SSH version 1 is vulnerable. And we know that when you install a Linux system by default, it supports both, right? So can you please make sure that your systems, our production systems, are only running version 2? And so one of the challenges with that is, okay, it's documentation. How do we go out and check our fleet? And I remember doing this myself back in the days where I would write a simple shell script, right? I would write a shell script, we can see in the top left box here, a scripting tool, right? So I would grep for the protocol in the SHD config file, and I would check whether it's version 2. If it's not version 2, I would probably manually change that configuration file. And so a testing language allows us to take this cross-platform, because that grep command would only work on specific subsets of Linux. It's not cross-platform compatible, but with a testing language such as RSpec, okay, we have now the capacity to express it once and maybe scan it on multiple systems. But for compliance purposes, what we also need to be able to add to those controls, we'll call them test controls or audit controls. What we need to be able to add is some amount of metadata, right? So things like the impact of the control. Is a failure of this test a breaking kind of failure, and we need to stop releases to production until we fix this? Or is this something that we just need to be notified on and make sure that we have it added to our exceptions and then sign off on it and promote, right? So you have to be able to not only run those tests, but to also assess whether those tests are critically valuable to you or just value of note. And so being able to add that kind of metadata to the control itself is valuable. And of course, and you know this as well as I do, that once you've written this test and you haven't touched this code in a little while, one day you'll come back to it, or someone else will inherit your code, and you'll look at it and say, hey, why did we even write this test? Why are we testing for this condition? So being able to describe the reasons why this control is in place. So we can say, for example, hey, SSH needs to be locked down to protocol 2 because of, I don't know, PCI paragraph 27, section 13. Right? And if we describe that as part of our control, when that fails, we have a very clear understanding of what part of our regulatory framework we should be concerned about. And of course, when we designed this, I mean, as I showed you, this example was strictly Linux because I think this audience for this webinar is very Linux focused. But we're Chef, and we produce cross-platform tools. The same code, the same language works on almost every other platform out there. So any flavor of Linux, Windows systems, AX, BBSD, Solaris. An example on the screen, we're looking at a control where we're checking the state of a registry key, and we're making sure it has a specific value. But checking IS systems can be interesting, right? Because you don't always have access to all of them. And so the InSpec binary, the executable that allows us to process this code to test our systems for compliance with this code, it allows us to test your machine locally, of course. Yeah, I can run InSpec exec against my Ruby file. But I can also test machines using SSH, right? So I can provide the key and credentials to my InSpec exec command. And what I will do is it will connect agentlessly to the system, right? It will use SSH to connect to the remote system. It will perform the tests, the controls that you've expressed in test.rb, and it'll come back with the result. Very similarly, that's how it works on Windows over WinRM. But guess what? It also works with containers. If you just have the socket information, very similarly, InSpec will connect to that container, run the controls you've specified, and provide the result for you. Now, all of those remote inspection mechanisms are agentless, which means I have no requirements for installing any kind of software prerequisites on my remote machine. And very common scenario that we've run through with a lot of my customers is we would come in, we would take some sample tests, right, sample controls, and point them at the existing production systems of our customers, because again, this is agentless, it's read-only, it's inspection-only, it doesn't make any changes on your systems. And we would scan the systems, we would scan their production systems, and we've seen customers who, in their minds, they were really sure that their systems are very secure. They would see the results of those scans, and they would see that there's a lot of work still to be done. And so being able to have an explicit framework around how your systems need to look like from a security standpoint is very, very, very helpful. Now, IS systems is fine, but we also take this beyond IS. So we now have capacity to inspect databases. So the example on the top allows me to run a specific query and expect that it should come back empty, right? We can also run inspect scans around APIs. So think about your cloud provider platforms, right? Think about expressing that a particular security group shouldn't have inbound rules that allow everybody to come in, right? What that means, what this enables us to do is to take our Azure ARM templates or, CloudFormation templates and make sure that not only do they deploy successfully, but they actually have security requirements in them, or they pass your security concerns based on what you've described in your control set. We call a collection of controls, we call them profiles. And so what we have today, right, and this is what we have on the left, is that our compliance teams are working mostly with spreadsheets and Word documents. Our security teams may be writing some scripts and occasionally running them. And then the DevOps teams are doing Chef or any of the other kind of configuration management and other rapid deployment frameworks. But really where we need to converge at is all of these different teams using similar sets of tools, right? So the DevOps teams should be able to understand and write some InSpec controls. Security teams should move away from writing one single platform shell script to InSpec, which allows them to do all of this work cross-platform. And the compliance teams can also own their requirements, their concerns in code, right? Because once they do, what that adds to the equation is it fixes for the gap that the DevOps teams and security teams have. I know that application developers do not have audit and compliance concerns top of their mind, right? Application developers, they want to write the feature, they want to implement or fix a bug. They're not directly concerning themselves with compliance and security. And so once we express those concerns in code and once those become tests in our pipelines, when those fail, now we have to have a conversation. The DevOps team or the application team has to have a conversation with the compliance team about the test and the code that failed and what needs to happen to the tests or to the application code, or maybe we just sign off and make this an exception. And so not only do we have to use similar languages, but we also have to use similar workflows, right? Traditionally, people, as we were talking about earlier, people working directly on machines is a no-no, because what that does is it leaves gaps in documentation and how these machines are built. And so the modern way, the way that most of you are operating today, is you're actually writing code, you're actually writing Chef code or partial DSC, Ansible, Salt, whatever you're writing, right? But then you're having that code be promoted through your pipelines, and that code runs on your systems and configures your systems. Very similarly, right, we have to enable our compliance and security teams to participate in the same kinds of workflows, where they also write InSpec for their security concerns and InSpec for their compliance concerns. And it very well may be that these different teams own different repositories of InSpec code, right? As a DevOps team, I probably own the functional testing pieces of my InSpec code. Security teams are probably locking systems down, and compliance teams, they want to make sure that the requirements of the framework that they're trying to follow are met. Right? So they may end up owning different repositories altogether, but what needs to happen is within those pipelines, those different code bases need to come together as tests for your code that you're trying to promote. And the workflow that we've seen our customers be successful with is very straightforward, right? Detect what's wrong with your systems today with InSpec, and then write a little bit of Chef code or any other CM code to remediate your systems. And this should be a continuous life cycle because we're always releasing new code, which means we should always be scanning systems for their security and compliance state, and probably continuously remediating as well. And one thing we need to make clear here is that InSpec is not a substitute for your antivirus tools or your penetration testing tools or firewall or intrusion detection, any of those, right? What InSpec becomes is part of your InfoSec toolchain. With that, it allows you to maintain a repository of your compliance controls that really matter to you as an organization, and then use those controls to continuously scan your existing production-grade systems, as well as be part of your test in your continuous delivery pipeline. Now, as I mentioned earlier, one thing that I want to make sure that you get away from this webinar is those additional resources that I'm going to push to the audience right now. These are the next steps that you can take coming out of this presentation. Go ahead, go to inspec.io, read up on the documentation. There's multiple examples for different kinds of resources InSpec supports. Go ahead and give those a shot. Now, the second link is very interesting because this DevSec organization on GitHub, they provide baseline InSpec profiles and Chef hardening cookbooks, which means you can scan your systems using those profiles and remediate using the cookbooks available there. Now, of course, doing any of this kind of work may be a little daunting at first, so if you want to sharpen your skills, go to Learn Chef, right? Learn.chef.io. We have tutorials there around writing InSpec. We have tutorials around writing Chef code so that you can get yourself the full picture. And of course, the Chef Supermarket is a public repository of multiple cookbooks available, built by us and built by the community. Now, I'm going to leave this slide up here because I'm sure that some of you may be clicking those links, some of you may be writing them down. I'm going to leave the slide up here, but I want to open up the Q&A section now. I know that we are 40 minutes into this presentation, and we've heard Matt Rathbun present on Secure Cloud in Azure, as well as this InSpec presentation. So I'm going to open this up for questions right now. You can use the Q&A interface within the webinar to ask me questions. I already see that some questions have been asked here, so I'm gonna start with this question here. Is it open source? Yes. So the InSpec framework, the language itself, as well as the executable, they are open source, right? And you should definitely start playing with those. As I mentioned earlier, our commercial product is Chef Automate, and what that enables you to do with InSpec is to really manage that at scale, right? Because if you're just managing a handful of machines, go ahead and use the open source tools. You'll probably be successful. But most of our organizations, we're managing hundreds and maybe thousands of machines. Doing that in a manual, remote fashion is kind of complicated. And so that's why Chef Automate is out there. It allows you to run those tests. So it comes with pipelines out of the box. It allows you to run those tests in those pipelines. It allows you to collect information about those scans into centralized dashboards, create reports, all of that beautiful stuff that you should be expecting at an enterprise level. All right, let's see. InSpec is agentless and can run anywhere. Is there a requirement to have Ruby available on a container? Yeah, I think at the least what we want to be able to have. Well, so you should, again, I would encourage you to try InSpec with your containers. It shouldn't need Ruby on the remote system. And this is why it's pretty much remote and can run anywhere. I know that I've run InSpec tests against Windows boxes that most definitely didn't have Ruby on them. All right, I'll mark this question as answered. Another question, could you please describe maturity level of InSpec resources for Windows? Yeah, I would encourage you to go to, as I said, and we can see on the slide, inspec.io. There's plenty of resources for Windows there. And the other thing that we do with Chef Automate, and this maybe ties in with the other questions, is we ship profiles, pre-written profiles for you with the product. What we've done as an organization is we've looked at the space of compliance, and we've seen there's PCI and HIPAA and SOX and many different frameworks, and all of them are a little vague around their IT requirements. So what we did as an organization is we said, hey, let's find a set of regulations that are very explicit. And what we did is we took Center for Internet Security Regulations, CIS, and we took all of their requirements and we expressed them in InSpec. And so if you launch Chef Automate or Chef Compliance from any of the available cloud marketplaces, what you should see in there is profiles that we have created for our commercial customers. And one of those profiles, or a set of those profiles, are CIS profiles for Windows machines. And I know that there are profiles for Windows Server 2012, 2016, Windows Desktops 10, 8, and they're very, very comprehensive profiles that conform to the CIS requirements. So if we're talking about maturity level of InSpec resources for Windows, I would say it's there on par with Linux, right? Now, InSpec, like many of the other frameworks that we make here at Chef, is fully extensible, right? And if the resources that we have shipped that are available to you are not sufficient, you have the capacity to extend those resources to write your own. But I'll tell you, the profiles that we ship with the commercial product are very comprehensive. And this is going to tie in with this other question that I'm looking at here. It says, how does this help us achieve HIPAA or PCI compliance? Because we ship these super comprehensive CIS profiles out of the box, what we've seen is that it takes customers to about 90% of their HIPAA expectations, to about 90% of their PCI expectations, to about 90% of their SOX expectations. Because at the end of the day, there's only so much you can lock down about your IT system, right? And so the CIS profiles, because they're very comprehensive, they cover a lot of that ground. And so what we've seen customers do is they would take our existing CIS profiles, they would harden their system to those requirements, and then the remainder of the work, the 10%, the 5% of the remainder of the work, is writing some amount of InSpec resources that are really custom to your organization, custom to how your organization chooses to interpret PCI, chooses to interpret HIPAA. Does this mean our compliance team needs to learn to write code? I think in the long term, the answer is yes, right? I think what we're doing here is we're allowing your compliance teams to not be blockers to increase consumption of elastic resources, but to instead be enablers, right? And I'll tell you, in the past 3.5 years, I've worked with our sales teams at Chef in the engineering capacity, and we'd go out and we'd talk to customers, and we'd talk to dev teams, and we'd talk to operations teams. I'll tell you, it almost never happens that we're having a conversation with a team that's looking to adopt some DevOps practices, and they have a security person in that room as well. And it's simply because traditionally the security people, they have this reputation for slowing us down, right? We're looking to write new features, looking to go elastic, and the security people are saying, hey, let's slow down, let's make sure that everything looks good, right? And so we want to turn that conversation around entirely and make security people enablers and a source of competitive edge for your organization instead of being bottlenecks, right? And the only way to do that is to have them participate in those rapid workflows. And if that means learning how to write a little bit of InSpec code, yes, right, that we need to do that. However, as you may have seen from my example, InSpec code is fairly easy to write, fairly easy to read. So yes, the role of the security and compliance officer is going to need to change, but what it does is it's really going to take them out of the basement, take them up and bring them into all of the wonderful conversations we're having around rapid delivery and make them enablers of those kinds of conversations. Let's see. Is there a quick start training available for InSpec to allow an organization to ramp up quickly? Yeah, so that's a great question, and I think it's the other version of what kinds of resources are available to help us write our InSpec profile. So there's two pieces to this. If you look at learnchef.io, one of the links on the slide now, there are hands-on tutorials that will allow you to kind of write this, some simple examples over a lunch break. The other piece, again, shipped with the commercial product, is a very comprehensive set of profiles. And then beyond that, we have training, so formal training on compliance, on InSpec and compliance, as well as our professional services team that can help you bridge that gap from what's shipped out of the box in terms of CIS that takes you, as I said, to about 90% of PCI. And our professional services team can help onboard your teams, right, to bridge that gap from 90% to 100% coverage. So yeah, multiple resources available for those looking to start you. There's hands-on tutorials that are really rapid, available on the website. There's formal training that I believe takes at least, I think it's a day of training. And then of course, we can have on-site engagements, professional services engagements with you as well. This is answered. We can use InSpec for network devices too. Possibly so the network devices that will allow you to SSH in and be there are some rights requirements, but I'm sure that some network devices can be inspected remotely. And really, it's about being able to SSH into the box and being able to have some amount of privileges to perform those scans, right? Like one of the things that it scans is config files that live in Etsy. So the least thing that we need to be able to do is have rights to look into Etsy, right? Or rights to look at the services table. So yeah, hypothetically, network devices can be scanned. There may be some practical restrictions or challenges there depending on what vendor and what kind of device we're talking about here. Chef Cookbook can provide compliance through configuration. What value does InSpec provide beyond recipes? Okay, so and this is very similar to how traditionally people were thinking about this, right? So we're saying, hey, so if I can lock down my system using Cookbooks, why do I even need to do InSpec? And what this answers for you is the challenge that we're seeing where multiple teams are writing different types of code, but your eventual production runs all of those pieces of code, right? So for example, you may write the cookbook that locks down your system, right? But someone else may write somewhere downstream from you will write a cookbook that for some reason installs the telnet service, right? And what InSpec really enables you to do is to scan the machine after all of the configurations have been performed. Right? And so you're saying, hey, I'm not going to allow telnet, and then the developer after the fact says, okay, I'm going to install telnet anyway. The developer will be able to install telnet, right? And so the only way for you to make sure that telnet has actually not been installed is not only to say, I'm going to write a resource to uninstall the telnet service, but I'm actually going to test. Is the telnet service actually factually uninstalled and not present on the system? So what InSpec is about testing the state of your machine more than locking it down, right? So you're going to want to write cookbooks to make your machine secure, but to prove to yourself and to your auditors that your machines are in fact secure, this is where you're going to want to run InSpec. And this is where the audit piece of this comes in, right? You express your compliance concerns in InSpec, and then you can audit your systems on demand at any time. All right, and see, we're going to take a couple more questions. Can we use InSpec to check AWS infrastructure configuration compliance? Yes, right? As I mentioned earlier, we have extended InSpec to be able to scan APIs. So one of the examples I had in previous slides was testing a security group for whether it had specific permissions. So absolutely, right? We're definitely taking InSpec to be able to test APIs. And the final question, does InSpec support Active Directory credentials to WinRM into remote boxes? Possibly, right? And let's have a conversation about this offline. I personally haven't experimented with this, but I'm sure that and you come from a very large organization, I'm sure very large organizations that are a customer of ours have the same requirements, right? So even if it's not there now, I'm pretty sure we're working on it. So if you want to follow up with me, my email is b@chef.io, and I will point you at the resources to help answer that question. Is it providing any compliance reports? Yes. So InSpec by itself doesn't provide reports, but our commercial offering, right, Chef Automate is the piece that allows you to gather all of that information, produce beautiful reports, perform scans on a schedule, and give you a view of your live state of your infrastructure as well as your pipelines and their security tab. Very cool. Thank you all so much for joining this webinar. As I mentioned, please follow up if you have any more questions. You can email me. It's very simple, b@chef.io. And if you're interested in trying this firsthand, reach out to our team. As I said, Learn Chef is a great place to have some hands-on tutorials. These offerings, Chef Automate, Chef Compliance, they're available in the various cloud marketplaces. Give those a spin. Reach out to our teams, right? If you're looking to put together a proof of concept or you want to do a more in-depth practical demo, like we can help you with all of those, right? All I wanted to make sure is that you understand that this is the new space that we're taking you to. We're turning your security concerns into competitive edge sources, and it really should enable your organizations to continue delivering software rapidly and to actually accelerate your rate of software delivery. Thank you so much.
Thanks, Bach and Matt. We're about at our time limit here. We, of course, hope you found value in the information that we presented today. And if you like what you saw, we encourage you to share the recorded presentation with your teammates or professional networks. The on-demand version should be available by tomorrow. Thanks again for your time, and have a wonderful day.